All right, so we're going to talk about word problems, everybody's favorite. The most important thing to do when you sit down to a word problem is actually really read all of it. We have a tendency to kind of just skim through it quick because we want to maybe get going, or maybe we're overwhelmed or for whatever reason. So make sure you actually read through it carefully, maybe twice, and then write out what it's looking for. Like focus yourself in on what it is the problem wants you to give at the end. Look for the keywords. You can circle or underline. You don't have to use any particular rule of what you circle, what you underline, how you do it. But then take what you have, think about what you need, and write yourself an equation. Often, I will make sure that my equation, if it has a variable, so let's say I decide that there's an unknown that's x, I'm going to off to the side write x is amount spent, or whatever I decide. When I define my variable, I try to intentionally define it thinking about what the question's looking for, right? Solve that equation, finding our solution, and then so helpful to go back and check your solution, see if it actually makes sense for the given situation, and see if you feel good about your math, because you can always back up, obviously. So here are some key words that we have when we sit down to a math problem, a word problem, that might help us find the correlated math operation. So we've got all these lovely words that really all of them are indicating that we're going to add, or they're the answer to an addition problem. All of these lovely words for subtraction. Be careful with multiplication and division. Product and quotient, nice and reliable, but be careful with per and each. Those have different meanings depending on the context. So if, for example, I said I bought 8 boxes of mac and cheese at the store, they were $2.75 each, how much did I spend? In that case, each is helpful for multiplying because I have the number of boxes and the price of the boxes I need to multiply to find my total. However, if I said I have $20 and mac and cheese is $2.75 per box, how many can I buy? Now I really need to do division because I have the total. I'm trying to go backwards to the amount I can spend to make up that total. So be careful. Context really matters for those. I'll add one more word, which is important, and it is. And this is going to go right along with equals or equals to. All of these usually are going to give you equals in a word problem. Not every time, but it's a helpful one to have. Just a few more specific vocab phrases. Consecutive. In our classes, we'll be talking about consecutive integers. That means they're always going to be whole numbers in a row, right? 7, 8, 9, 10. It's a straight in poker. So if your first number is something we don't know yet, the next one is going to be one more than that, and then 2 more, and then 3 more, etc., etc. So you start with what you don't know and just give it a variable like x, and then the next consecutive integers will be each one of them one more than the previous. Similarly, if you get consecutive odds or consecutive evens, you're starting with some number you don't know. You can label it any old variable you like. And then when we go through these consecutive odds or consecutive evens, imagine you're counting 12, 14, 16, 18, or you're counting, I don't know, 31, 33, 35, 37. And all of those, we're skipping a number each time, so we're increasing by 2 every time. So that's how we would set up our unknowns for consecutive odds or evens. So let's do a little bit of practice on these. When we have 5 more than a number, we're going to try to write that now as an algebraic sentence instead of an English sentence. So I'm going to use x as my a number. So I'm going to say that's x, and if I want 5 more than that, I'm adding 5. Please feel free to pause me and do these on your own if you'd rather, and then you can just test against mine at the end. Double a number added to 15. I'm going to write 2 different ways we could write this because it doesn't really matter. So I could say I start with 15 and I add double a number. That's going to be 2x, or x times 2. So I could write it as 15, and then you add the 2x to it. But if you know that 2 plus 3 is the same as 3 plus 2, in addition, that order doesn't matter. We could have written this as 2x plus 15. Either way, in addition, that order does not matter. All right, the product of a number and 7. Product should be reminding us of multiplication. I'm going to keep using x for my a number. So if I just write this out like following this along, a number times 7, perfectly good way to write it. You will more often see it written as, for example, 7x. Mathematicians do not put that little tiny times in there. We assume a coefficient next to a variable means you are multiplying those two things, 7 times x. And that's how we could read this, 7x is 7 times x, but we don't always write it out. So this is the more common way you'll see this. This is also completely correct, so don't stress. All right, the difference of two numbers is 11. Love that. For me, is 11. That part's nice and easy to write. Difference is telling me I'm doing subtraction, but other than that, I don't know anything else. This is just like two numbers, so two unknown things. We don't know what they are. I'm going to give them two letters. Better be different because I don't know that these are the same number, right? So let's call this x and y, and since it's difference, we are subtracting them. X minus y equals 11. All right, 3 times a number increased by 4 is equal to 19. So definitely equal to 19 at the end, nice and easy, okay? 3 times a number, we could write 3 times x increased by 4 plus 4 is equal to 19. Lovely, perfect. Why did I leave extra room? Well, I paused at very specific points when I read that phrase, and you might pause at slightly different points, which make this whole thing sound different. Listen, 3 times a number increased by 4 is equal to 19. And listen, if you don't have to spend all day doing math, you might not think about this as much as me, but a number increased by 4 could be one thing altogether, right? A number increased by 4, and then we're multiplying that whole thing by 3. This sentence is slightly vague, so you could have read that into either of these. These are both correct interpretations because this sentence is not completely 100% clear. So if you run into a sentence like this where you don't really think you know what it means, it's like slightly vague, please ask a question. That's a time to clarify how the instructor, whoever wrote it, wants you to read that. Ideally, we should always be writing sentences that do not have multiple ways to interpret them, but we're not perfect. All right, the quotient, we should be thinking about dividing, of 12 and a number. Now, just like subtraction, division, the order matters a lot. So if they said 12 and a number, that means we are starting with 12 and dividing it by a number. That is different than if we said the quotient of a number and 12, okay? And then last we have the sum, we're adding two things together, of two consecutive numbers. And for now, I'm just going to leave these blank. So I'm going to decide what my first one is. And I don't know what it is, right? So I'm just picking a letter for it to be. I'm going to say Z just to be crazy because everything else has been X and Y. So we have Z, and then we want the next one, the next consecutive number. And remember, that just means it's one more than it. So one bigger than the thing I had right before.